All right, in this lesson, we are going to apply the properties of logs to condense and expand logs. So as we work through that, the essential question, there's actually two that I want you to be thinking about, is the product property of logs associates multiplication with which operation, and the quotient property of logs associates division with which operation. So let's go ahead and get started. There are three properties that we're going to focus on: the product property, the quotient property, and the power property. These are all terms we've heard before. We've used the product property, the quotient property, and the power property when we've dealt with exponents, and that's what we're dealing with today. All right, so let's talk about what the product property actually says. So it says log base b of two numbers being multiplied together. So when those two numbers are being multiplied together, I can rewrite that log as log base b of m plus log base b of n. So the product property basically says if I see two logs that are being added together and they have the same base, that is essentially the same as taking the log of that base of those two numbers being multiplied together. These properties are going to be really important as you move forward in your math, so in your pre-calc and your calculus classes. So make sure that you're understanding those connections. So when I see something like number 1, where it says log base 2 of 7 plus log base 2 of 4. So one of the things I noticed is that addition is happening. I also noticed that the bases are the same. So I can condense it into a single logarithm, which is my goal, by using the product property. So I can say that log base 2 of 7 times 4 is going to be the same way. So I've condensed it into a single log. So here it was 2 logs, and I was able to use the product property that says addition actually means multiplication when I have the same log and base. And then I just simplify 7 times 4. And so my answer here is log base 2 of 28. Now you may be thinking, okay, why are we doing this? Well, eventually in our lessons later on, we're going to be actually solving. And we need to know these properties really well and be able to move between the two formats in order to solve those equations. So what I'd like you to do is pause the video, and I'd like you to try number 2 on your own. So log 25 plus log 4. If you notice, they don't have a base that's explicitly written there, but what do you know about the base that is actually there? So pause the video and try this one on your own. So hopefully you were able to remember that if there is no log written there, it's automatically a 10. And so they both have a log base 10. So I can use the product property to rewrite it as log of 25 times 4, which is the log of 100. All right, let's go on to number 3 and see if we can figure this out. So I'd like you to pause the video and try to rewrite it into the product formula. All right, so hopefully you were able to rewrite it as log base 4 of 2x times 4x squared, which that simplifies into log base 4 of 8x to the third, because I multiply those coefficients and I add those exponents. All right, so now we're going to work ourselves backwards. So we're going to expand using the product property. And I will let you know that the answers may vary on these, so you may come up with a different exact answer as me, but as long as it still works, that's okay. All right, so let's talk about number 4. So I see that it's in log form. It's one single logarithm. So I can use the product property to take that one single log and expand it into 2 logs that are being added together but that still have the same base. So essentially I'm looking for what factors of 6 could I rewrite it as. So I could use 6 and 1, or I could use 3 and 2. It really doesn't matter. So I'm going to choose 6 and 1. So it would be log of 6 plus log of 1, because if I use the product property and work backwards, it would end up being log of 6 times 1, which then simplifies to the log of 6. You could also have the answer log of 2 plus log of 3. Or, because in multiplication and addition order doesn't matter, it could also be log of 1 plus log of 6 or log of 3 plus log of 2. So that's why the answers may vary, just as long as these two numbers multiply to be that value. All right, so go ahead and pause the video, and I'd like you to try number 5 on your own. All right, so for number 5, you could have any of these 3 answers. You could have log base 7 of 1 plus log base 7 of 45, because 1 times 45 is 45. You could also have log base 7 of 3 plus log base 7 of 15, because 3 times 15 is 45, and then the same is true for 9 and 5. So as long as you got one of those combinations, and again, you could have them in a different order, but those same numbers have to be together. All right, let's look at example 6. And this one is a little tricky, but I think we can figure it out. So log base 2 of 5x. So I'm looking for, just like I did over here with 45, what 2 numbers multiply together to give me that 5x? Well, the only way I can see it is 5 times x. So when I expand my log, it would end up being log base 2 of 5 plus log base 2 of x. All right, go ahead and pause the video and take note of any of the answers that you're confused on or you have questions about. All right, so the next property that we're going to talk about is the quotient property. And so the quotient property says that when I have log base b, and they have the same base, of 2 numbers that are being divided, unlike the product property that was talking about 2 numbers being multiplied, I can rewrite that log in an expanded form of log base b of m minus log base b of n. So this quotient property goes both ways. I can take something that's being divided and write it as 2 subtraction logs, or I can take 2 logs that are being subtracted and rewrite them, condense them into 2 logs that are being divided. So the quotient property says that division and subtraction go together. So let's go ahead and look at number 7. It's wanting me to condense it into a single logarithm. So I'm going from an expanded form to a simpler version, and it's asking me to simplify if possible. So if I'm going from subtraction to division, chances are I might have a fraction that needs to be simplified. All right, so we have log base 3 of 24 minus log base 3 of 8. And I notice that it is subtraction, and I have the same bases. So I can rewrite this as log base 3 of 24 over 8, because they're being subtracted. So when I put them together, they will be divided. And I can simplify. 8 goes into 24 3 times, so my final answer is really log base 3 of 3. All right, so I'd like you to pause the video and try number 8 and number 9 on your own. All right, so for number 8 and 9, hopefully you were able to get these answers. If you didn't, then I'd like you to pause the video and write down any questions or identify any places where you're confused about my work or my answers. All right, so now we're going to work backwards. And again, just like we had with the product property, your answers will probably vary from mine. But as long as at the end of the day, when I divide the 2 numbers, I get 4, it doesn't matter what values I use. So I'm going to look at number 10, and I'm going to say, okay, log base 8 of 4, I'm going to expand using the quotient property. So the quotient property says that when I divide 2 numbers, the answer is 4, and I can expand it by taking those 2 numbers that are being divided and subtract them. So the number I came up with was log base 8 of 8 minus log base 8 of 2. So when I think about it, 8 divided by 2 gave me 4, so I was able to rewrite that as log base 8 of those 2 numbers being subtracted. So go ahead and pause the video, and I'd like you to try number 11 and 12 on your own and see if you can just come up with what the expanded version is. All right, so for number 11, probably most of you came up with log base 5 of 1 minus log base 5 of 3. You could have also done any sort of multiple that divides to 1/3. So you could have done something like log base 5 minus log base 5, log base 5 of 5 minus log base 5 of 15, or log base 5 of 3 minus log base 5 of 9. Anything that when I take those numbers and put them back together, I get a fraction that reduces to 1/3. And then number 12 was pretty easy. It's a log base 10, so I don't have to write that base in. And it becomes log of m minus the log of 7. So before we move on, make sure that you identify any of these answers that you don't understand, that you want to talk about. Put any notes or questions that you might have. So pause the video if that is the case. All right, so the final property that we're going to deal with logs right now is the power property. So the power property says that log base b of m to the n can be rewritten as n times log base b of m. So essentially what happens is we just take that exponent and we put it down in front of the log base b of m. So this is kind of an easy property in that you just simply have to look for that exponent if anything's being raised to that power and simply bring it down in front and multiply it by the log that exists. So let's go ahead and try some problems out. So number 13 says 5 times log base 4 of 2. So it wants me to condense into a single logarithm. So right now it's currently in this state, and I need to put it into the condensed form. So I know that to put it in the expanded form, I simply took that exponent and put it out front. So that means that this 5 is now going to be put back as the exponent of the 2. So my answer to number 13 would be log base 4 of 2 to the 5th. And I can simplify 2 to the 5th as log base 4 of 32 because 2 times 2 times 2 times 2 times 2 is 32. All right, so go ahead and pause the video and see if you can write the remaining 2 problems in condensed form using the power property. All right, so 14, hopefully you were able to get log base 2 of x to the 7th. So that exponent simply comes out, or I'm sorry, that 7 simply comes out and becomes an exponent. Now on 15, I would accept either of these 2 answers. We've talked a little bit about exponents as fractions, and essentially what that means is if it's 8 to the 1/3, the 8 to the first part, so the numerator goes in the square root or the radical sign, and then the denominator tells me what root I'm taking. So in this case, I'm taking the 3rd root of 8. If you didn't put that, that's okay. As long as you got to this part, for the sake of right now what we're doing, we'll work more with radicals later. All right, so the last 3 questions on this is we are going to expand using the power property. So we're going to work backwards essentially. So we're going to rewrite this into its expanded version. So when I look at this, I know that this exponent 7 is simply going to come out in front. So my answer to this is going to be 7 times log base 2 of 8. So go ahead and pause the video. I'm going to have you try 17, and then I'm also going to have you try 18, but let's go ahead and rewrite number 18 together so that it's already in the exponent form. So it's w, the square root of w. So when we talk about up here, it was the 3rd root. So we divided by 3. So this is the square root, and we've only ever really dealt with squares, and so squared means to the 2nd power. And the w is being raised to the 1st power because there's no other exponent there. So I can rewrite this log as log base 7 of w to the 1/2 because that's another way of writing square rooting. So go ahead and pause the video, and I'd like you to expand using the power property. See if you can expand these logs. All right, so for 17 and 18, 17 was a little tricky, but I wanted to see if you remembered your algebra skills. So I'm taking this whole value of x minus 1 and putting it out front. So I put it in parentheses to represent that it meant one number. And if I'm multiplying that by the 3 that already exists out there, then I distribute my 3. And so I have 3x minus 3 as a value that's being multiplied by the log of 4. And for 18, you should have ended up with 1/2 log base 7 of w. All right, so that wraps it up for our introduction to the 3 properties of logs that we're going to be using. I'd like you to take a minute and we're going to do some reflecting before we close out this lesson. All right, so I'd like you to pause the video in just a minute, and I'd like you to write down 3 common mistakes you think students tend to make with the properties of logs. So where are some places that you think they would make mistakes? And then so far, what is your summary for this topic? So be as detailed as you can because we talked about 3 different really specific things. And then on a scale of 0 to 3, what's your comfort level with this topic so far just based on this video?